Three-dimensional coordinate systems, Level 1. Calculus 3 is a course that uses all the concepts learned from Calculus 1 and extends it to the study of functions with two or more variables. In a nutshell, Calculus 3 is Calculus 1 in 3 dimensions. Nothing more, nothing less. With that said, this class will challenge your spatial visualization skills and push them to the limit. Before we dive in, we need to start thinking three-dimensionally and be familiar with a three-dimensional coordinate system. We first need to remember the basics of number lines. Back in Algebra 1, and perhaps even before that, you learned that a number line is formed when a numerical value is assigned to each point on a line. For example, the following line represents a number line, and point A is located at -1. Likewise, point B is located at 1.5, or written another way as 1.5. Notice that number lines are useful to describe the location of a point relative to the origin, which is usually assigned a value of 0. In other words, a number line can be viewed as a coordinate system, specifically a one-dimensional coordinate system, consisting of all the points on a straight line. Notice that this line is broken into two regions, or halves. The first half contains positive numbers, and the second half contains negative numbers. And for the most part, you can only move along the line, either infinitely to the left or infinitely to the right. In this sense, a one-dimensional coordinate system is equivalent to a number line, where every real number, whether rational or irrational, has a unique location or position on the line. Conversely, every point on the line can be interpreted as a number in an ordered continuum that includes the real numbers. We can mathematically denote this one-dimensional space that includes the set of all real numbers as follows, using the real number symbol. Now, if we take this number line and introduce an additional number line that is perpendicular to this number line, we obtain the modern coordinate system, also known as the Cartesian coordinate system, or the rectangular coordinate system. A two-dimensional coordinate system specifies each point uniquely in a plane, also known as the XY plane, as opposed to a one-dimensional coordinate system, which specifies each point in a straight line. As a result, a point on a two-dimensional coordinate system is described by a pair of numerical coordinates, also known as an ordered pair. Each coordinate in the ordered pair describes the location of the point along each number line, which are commonly known as coordinate axes. The value along the x-axis, also known as the abscissa, is called the x-coordinate of the ordered pair, and is denoted first when describing a point on the plane. Likewise, the value along the y-axis, also known as the ordinate, is called the y-coordinate and is denoted second when describing a point. Together, the x and y coordinate form an ordered pair. Notice that a point is measured relative to a common center, where the two number lines intersect. This common point of intersection is called the origin, and is usually labeled by using the letter O. The ordered pair that describes this point is written as follows, 0, 0. As an example, the following 4 points can be described as follows. Point A is located at 2, 2. Point B is located at -1 and 1. Point C is located at -2 and -3. And point D is located at 4, -3. As you can see, each point forms a rectangle when applying their position, hence the rectangular coordinate system. Also notice that a two-dimensional coordinate system is broken up into 4 regions, also known as quadrants. They are usually labeled as follows: Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. In addition, the sign for each coordinate of an ordered pair is dependent on which quadrant the point is located. If the point is located in Quadrant 1, both the x and y coordinate will be positive. In Quadrant 2, the x coordinate will be negative, and the y coordinate will be positive. In Quadrant 3, both the x and the y coordinate will be negative. And finally, in Quadrant 4, the x coordinate will be positive, and the y coordinate will be negative. In a two-dimensional coordinate system, you are free to move along 2 lines, infinitely to the left, infinitely to the right, infinitely up, and infinitely down, as opposed to just one line, like that in a one-dimensional coordinate system. Mathematically, we can define all the points in a two-dimensional coordinate system by the Cartesian product r times r, or r squared, where r squared represents the xy plane, and it consists of all the ordered pairs where the values of x and y are elements of the real numbers. Let's move along and talk about the three-dimensional coordinate system, also known as the three-dimensional rectangular coordinate system. If we take the two-dimensional Cartesian axis and add an additional number line perpendicular to both axes, we obtain a three-dimensional coordinate system. The three-dimensional coordinate system contains 3 coordinate axes that intersect at a common point, also called the origin. These include the x-axis, y-axis, and z-axis. For the most part, the x and y-axis are horizontal lines, and the z-axis is a vertical line. Just like the previous coordinate systems, each axis contains positive values and negative values. On the x-axis, the positive values are located here, and the negative values are located on the opposite direction. On the y-axis, the positive values are located here, and the negative values in the opposite direction. And finally, on the z-axis, the positive values are located here, and negative values in the opposite direction. A way for you to remember where the direction of the z-axis is located is by using the right-hand rule. If you curl the fingers of your right hand around the z-axis counterclockwise from the positive x-axis to the positive y-axis, then your thumb points towards the positive direction of the z-axis. In addition, the three coordinate axes also determine three coordinate planes. The xy plane is a plane that contains the x and y axis. The yz plane contains the y and z axis, and the xz plane contains the x and z axis. Together, the three coordinate planes divide space into 8 regions called octants. This is analogous to the quadrants of a two-dimensional coordinate system. In this case, a three-dimensional coordinate system divides space into octants. The first octant is determined by the positive axis. If you're having a hard time visualizing this, just look at any bottom corner of a room. That's essentially a visual representation of the first octant. The wall on your right is a YZ plane. The wall on your left is a XZ plane. And the floor is a XY plane. In the same manner, there are 7 other rooms, 3 more on top and 4 more on the bottom. If you imagine this three-dimensional coordinate system representing a 2-story building, there will be 4 rooms on top and 4 rooms on the bottom, each room sharing a common corner called the origin. In a three-dimensional coordinate system, a point is located in space, as opposed to a two-dimensional system where a point is located on a plane, and a one-dimensional system where a point is located on a line. With that said, we represent a point by an ordered triple, x, y, z, of real numbers, and we call the numbers the x, y, and z coordinates of the point. In order to locate a point in space, we first start at the origin and move along the x-axis to locate the first coordinate, then move parallel to the y-axis for the second coordinate, and then parallel to the z-axis to locate the last coordinate. The reason why this coordinate system is called a rectangular coordinate system because points in space determine rectangular boxes. For example, the coordinate 4, 5, 3 is plotted as follows. We first move along the x-axis, 4 units in the positive direction. Then we move 5 units parallel to the y-axis in the positive direction, and then move parallel along the z-axis, also in the positive direction. Now at first it's a little hard to see where the point is located, so we need to draw a corresponding box so we can get a better perspective and visualize this three-dimensional plot on a two-dimensional sheet of paper. The way we draw the box is actually pretty easy. All we need to do is draw 3 additional lines with the same length for each coordinate. So here we draw 2 lines parallel to the first coordinate that starts from the point 0, 5, 0 and ends at 4, 5, 0. Another one that starts from 0, 5, 3 and ends at 4, 5, 3. And lastly, one that starts from 0, 0, 3 and ends at 4, 0, 3. Then we draw lines parallel to the y coordinate, 1 for the bottom and 2 for the top of the box. Then we do the same for the z coordinate. We draw lines parallel to connect the bottom and the top of the box. In the same way, the following points will be plotted as follows. Point B will be located at 4, -6, and 6. Point C will be located at -3, -3, and 2. Point D will be located at -6, 3, and 4. Point E will be located at 4, 5, and -5. Point F will be located at 4, -6, -5. Point G will be located at -3, -3, -2. And point H will be located at -6, 3, -4. This is how the points will look like in a sheet of paper. Let's actually plot these points using a 3D plotter. Point A will look like this. Point B, point C, point D, point E, point F, point G, and finally point H. So we grab this Cartesian plane and move it around like this. We see that we have 8 distinct points 4 of them on top of the XY plane, and 4 of them on the bottom of the XY plane. 1 for each octant. So it's really hard to see this by just using a 2-dimensional sheet of paper. But by using technology, we can actually see a better representation of how these points look like in 3-dimensional space. Just like the quadrants of a 2-dimensional coordinate system determines the sign of each coordinate, so does each octant. On the first octant, all 3 coordinates are positive. In the second octant, the x-axis is negative, and both the y and z axes are positive. In the third octant, both x and y are negative, and z is positive. In the fourth octant, both x and z are positive, and y is negative. In the fifth octant, both x and y are positive, and z is negative. In the sixth octant, x and z are negative, and y is positive. In the seventh octant, all 3 are negative. And finally, in the 8th octant, x is positive, and both y and z are negative. In a 3-dimensional coordinate system, you are free to move along 3 lines: infinitely to the west, infinitely to the east, infinitely north, infinitely south, infinitely up, and infinitely down. Mathematically, we can define all the points in a 3-dimensional coordinate system by the Cartesian product r times r times r, or r cubed, where r cubed, in this case 3D space, consists of all the ordered triples where the values of x, y, and z are elements of the real numbers. Alright, make sure you're comfortable with this new 3-dimensional coordinate system. It's going to be key in understanding the rest of Calculus 3. In our next video, we will focus on graphing equations using this new coordinate system.